Hello everyone, in this video we are going to look about maps in STL. It is yet another container in C++ STL. It plays a very important role in the world of competitive programming. It literally optimizes many problems by just taking some extra space. It is a great way to store elements as well. You can think about it as a dictionary in Python or a JSON object or JavaScript objects. So before moving further, let us see how does the map works internally. So as you can see, maps are associative container that stores elements in a map fashion. It means that it associates a key to a value actually. Suppose you can think it as of mapping a roll number to a name. As you can see here, this is the syntax for declaring a map. It just maps a integer value to a string. So you can think it as of integer as a roll number and string as name. So the basic idea behind map is binary search tree. So internally the map store element in the form of binary search tree. So how does it look like? Is this. If you insert a element in a map, then it creates a node of a tree and stores it. So basically it is mapping roll number 5 to zone. So if you insert one more element, suppose mark of roll number 8, it will insert the node to the right side of zone because 8 is greater than 5. Next node is 7. So it's basically mapping roll number 7 to Diego, which is again stored in to the right side of 5 but the left side of 8 because it's greater than 5 but it's less than 8. So in the similar fashion, it maps more element, creates a binary search tree. So basically for any operation like inserting, deleting or updating values, it just takes the same amount of time the binary search take, that is the height of the tree. That is the worst case complexity. Suppose it is a skewed tree you can think of, then it will take like the number of elements, so the height of the tree will be very large. So it all depends upon the height. And the height of the balanced binary search tree is log n. So this tree like always balances itself. So it's a great way to store element and perform search operation. Suppose you perform binary search, it's find the element in the log n time, that is less than n. So this is the idea behind binary search as well. And just to note one point, it is map and store in the form of binary search tree. We'll be seeing one more version of map, that is unordered map. So basically it is ordered map. It stores the element in the ordered sequence based on the value of key. So let's start with the code. Then the first and foremost thing for using maps is to include the header file for map. It's a map just, and let us include other. Okay, we'll be using namespace as std. Okay, let us check that this map is successfully imported in our project or not. It's successfully compiled, and okay, so it is successfully imported in our project. The first thing we are gonna look at is the constructor, how to basically declare a map. So I'll pasting down the syntax out here. So this is the basically the syntax of declaring map. So let us declare a map. So it's just map. We are gonna map integer value to a string. So basically it's create a map which maps the integer value to string, basically a roll number to name. That's the idea we are having here. So the next thing we are gonna see the another way to declare a map. So the another way you can declare a map is like this. We'll be again mapping the same thing. Let us name it m1. So you can declare like this also. So this declares a map and for putting value you need to pass value like this. So let us consider this as roll number and this is as name. So basically it's also declare a map and initialize it with 40 as a key and Rohan as a value. So it maps 40 to Rohan. So we'll be using this map in our further process. Let us see how to insert a value in a map. So we can insert a value in a map like this. So this is the first map we'll be using. Let us comment it out. So it's m, it's 40. This 40 is mapped to this integer and this string value is mapped to this string. So its key, its value. So let us see it is successfully mapped or not. So just do m of 40. So it will return you the string value Rohan. So let us check that it is successful or not. So as you can see, it returns Rohan. So it's successfully mapped 40 to Rohan. The other way for inserting values to the map is insert keyword. So basically m dot insert. So as you can see, insert keyword, but here you need to pass a pair to this insert function. The pair we are gonna look further in the STL series. It is also a utility in STL. So this is how we declare a pair, and we'll pass suppose 41 roll number to zone, suppose. So it's also passes inserts actually value to map. Let us check that it is successfully inserted or not. So as you can see, it's written John. So these two are different ways to insert values to a map. So let us check like how the iterator work. Basically you can iterate through the map and check various value it's consist. So for that we'll be declaring an iterator, as we have seen in the vector series how to declare an iterator. Suppose you first you need to have the map same type as you will be iterating through. So just declare an iterator keyword and name the iterator. So basically the name of the iterator, and you can pass on this as m dot begin. So begin returns the base address of the map, as we have seen in the vector series also. So for iterating this map, the iterator is just a pointer, so we can compare it with the end address of the map actually. So this end return the end address, and as it is pointer we can just do plus plus and it will iterate through the various address of the map. So let us see how we can retrieve the value of key and value. Suppose this is key and key is retrieved as it. You need to use this arrow keyword actually for retrieving the value. So next, suppose we are gonna retrieve value. So again same thing, second. So this is the keyword you have to use for retrieving the value actually. So this is actually used in pair. So whenever you do this, it's return a pair actually. The map stores the value as a pair, so it's return a pair. So as we are gonna see that this is actually a function of pair utility. So let us comment it out, or have a fresh input. Let us compile and check. As you can see, key is 40, value is Rohan. This. So basically it's a great tool we can use, and it basically optimize various problems just by taking some extra space. Various problem of n square, big of n square time complexity are reduced to big of n by this container actually. So let us check some other function. Next function we are gonna check is app is empty or not. So basically there is one function m.empty like this. It's basically return the true or false. So we'll pass this like to if else statement and check that this is empty or not. So we'll passing map is empty. So else we'll do map is not empty. So let us see, we're compiling it. As you can see, map is not empty. And suppose let me remove this value as well, so it will return true and we'll get the output map is empty. As you can see, map is empty. So it's a great utility for maps.empty. It's used in various places. So let us see our next function, that is size. Size return the size of the map. You can use it in various way as well, in wherever you required this. As you can see, it returns 2. There are 2 pairs actually stored this in this map. There is various other function like clear. You can see clear map m.clear basically clears the whole map actually. So it clears all the value and returns an empty map actually. So let us see, like this is we'll put this statement after clearing. As you can see, map is empty. So this clear function actually removes all the elements of the map. So it's a great tool you can use. You can also have like a map of other data types and containers actually. You can also have like map of string to vectors actually. So something like this, it might be used, like you can use it according to your convenient, like where you are gonna use. Okay, so we have not included this vector, that's why it's showing error. So let us include this vector as well. So it will go, I think now error will go. So as you have seen, it is gone. So basically according to your need, you can create any type of map, like which maps to values. You can map string to string, you can map string to integer, you can map integer to float, something like this. It just map one value to another. There is one more great utility function that we can see. Let us like remove this code actually. Okay, so the other function we are gonna see is find. So find allow us to like find a key actually. So if key exists, it returns the iterator to that particular element pair, and otherwise return the last iterator actually. Let us see how we can use it. So basically auto is basically a keyword. Like if you declare it as auto, it automatically assigns the data type to it, that is assigned to it actually. So m dot find basically it's return a iterator, so the type of it will be iterator. So it was already defined here, so let us use it1. So it1 find, let us find 40. So basically it will find 40 as a key. So let us see, if it1 is not equal to m dot end, then we'll see that 40 is found. Sorry, 40 is found. Else we'll say that 40 is not found. Great. So let us test it. Like let me clear it. Okay, successfully compiled. As you can see, 40 is found. Let us try for some element that is not present, 100. Forty is not found because as we have written this element like statement. Okay, I'll do it 100 then. Great, let's compile. 100 is not found. So like this map is really great. It's like optimizes various problem. We'll be seeing like another map in the next video, I think. So that's also a great utility that also reduces time complexity very much, and you can use it in various problems. So you can use this map in your way actually, based on the problem. we'll be seeing that in another map there are various tools as well you can use. So like depending upon the problem definition, you have to choose between the map or another map basically. So there is some slight difference between map and another map functions. So let us see another map as well in the next tutorial.